So back to our speakers. Today, I've got Dr. Jackie McRae, who's the manager of the ARC Graphene Research Hub. And Jackie joined me last month in Adelaide, where we had a great event with the American Chamber of Commerce in Adelaide. Actually, it was a full house there, Jackie, wasn't it?
Yeah, it was good turnout.
And so good to see that since our last Zoom seminars, the talk about manufacturing has only grown. And I've been able to go across Tasmania and through South Australia. I'm heading to Queensland next month. And no matter where I've been, no matter what factory I've been visiting, everyone that I talk to is busy. And probably the number one issue that I hear out there is that you're having trouble finding staff. So this is not a bad problem to have, I think, for manufacturing across Australia. A bit about Jackie. As I mentioned, she's the manager of the ARC Graphene Research Hub, based at the University of Adelaide. She joined the team in 2019 after 10 years as a research scientist at the Australian Wine Research Institute, having completed her PhD in organic chemistry in 2008. Jackie's actively involved in the business development and stakeholder engagement of the Hub's research program, as well as managing the activities and project milestones in collaboration with teams across 6 universities and 5 industry partners. She certainly is passionate about translating research outcomes into industry solutions. And it's a commitment to the Hub and the ultimate goal of developing a sustainable graphene manufacturing industry in Australia. And that's certainly the case. And you had a lot of questions at the seminar in Adelaide, Jackie, so I think we'll keep you busy today as well.
Yeah, it's really good. There's a lot of interest. It's a really good area to be in.
Glad you could join us. We also have Neil M. Armstrong. Neil is the commercial manager at First Graphene. And we'll hear a bit more about the company shortly. But Neil's an effective and hands-on problem solver. He's certainly driven by innovation and sustainability. We'll hear more about that. But Neil played a critical role in the design and commissioning of First Graphene's world-leading production facility in Henderson, in Western Australia, developing new equipment and processes focused on the commercial scale production of graphene and its industry applications, which are only growing by the day, right?
Yeah, absolutely. Yeah, it's keeping us very busy.
And Neil's got a strong engineering background in the mining and resources sector, designing and implementing innovative solutions aimed at efficiency and reduced downtime, which is always a big one in mining. As an example, after looking at landfill in the northwest of the state, filled with used conveyor belts and the like, Neil invented a novel technology that can target and repair accelerated wear locations across conveyor belt surfaces, significantly increasing the life of the belt whilst reducing the associated waste and costs of replacement. So that would have been good work, Neil.
It's a bit nerve-wracking seeing the first trial, that was for sure, when we sort of go across the head pulley and hoped everything would stick together, for sure, yeah.
Very good. So as you can see, Jackie's in the tropics.
Yeah.
I'm in the mobile Zoom studio, which some people call a car. And Neil's coming to us from Perth today, so we're all over the place. But with the wonders of modern technology, we've all come together. And thanks to our great team at AMGC, I'm going to have some slide decks come up. So we'll be able to share some of our latest research from AMGC. And there's our speakers today. And as we know today, we're specifically targeting and talking about how R&D can add value to your business. So feel free to drop any questions as we go using the Q&A button at the bottom of the screen. But I thought at a start, I'd talk about Industry 4.0. That's the call that we hear. And quite often I'll get people asking me, what does it mean? What is Industry 4.0? And so I like to go through these slides to demonstrate how far we've come. So if you think about it, the first industrial revolution, or Industry 1.0, was in the 18th century with steam power, and it changed the whole world. Suddenly we could do production like we'd never seen before, and it changed everything that humans did. We came together and in most instances came off the land to produce goods that we could sell to our neighbours and people further afield. So Industry 1.0 in the 18th century. Industry 2.0, think about mass production. Think about Henry Ford and how he transformed mass production and aligned it to what we have today. Again, it was a major step change in manufacturing about how we go about making goods. And certainly the Ford Motor Company still continues strong to this day. So I'm sure that Henry would be looking down and looking at the great work that he was able to do in that industry transformation. or Industry 2.0. Now, Industry 3.0, or the third industrial revolution, is pretty much when I was at school, and it was all about computers. And I vividly remember my school teachers saying to us, you guys are going to have it so good. You know, with all these computers and the way it's changing the world, you'll probably only work a 3-day week. I'm not sure how that's working out for you guys, but it seems to me that we're doing a lot more than that. In some ways, it's 3 days plus 3 plus 3, and we're just busier than ever. But that was the call, that industry would change dramatically. At the time, Bill Gates put out a book called Business at the Speed of Thought, and he was showing how not just computers, but the internet would change everything. Things like email, and we'd have a paperless office. So I'm not sure about the paperless office, but email did change everything. And I know that even now as I'm talking with you, the emails will be piling up. So here we are today at Industry 4.0, the fourth industrial revolution. And it's all about this intelligent production. And it's, as you can see there on the slide, we've progressed so much more than just making things. And today we're talking about R&D, but you'll see there that we're talking about design and logistics, distribution, sales, and services. This is a transformation. This is modern manufacturing. And this is the research that we've been publishing to show how Australia can take a leadership position. So it's much more than just production, but also more than the value that can be created. So you'll see there what we call appropriately the smiley curve. At the extensions there around R&D and services, we're seeing that that's where the greatest increase in value can be created. And I'm sure that Neil will talk to us a bit about what First Graphene have done with their R&D in particular to grow that business. So have a look at all this research that we have on the AMGC website. But just one business you might like to have a look at, one of the projects we've done is with a company called 36T, Partington Engineering in Victoria. They've developed a lightweight composite bicycle wheel, which they've designed and worked with researchers to develop, and looking at exporting these high value bicycle wheels globally. So this is how we can create value right here in Australia, but then drive industry transformation and create value for all of us here in Australia. The one thing that has changed during COVID that we've seen is that suddenly the whole world is talking about manufacturing. And Jackie, we've seen the Australia Made campaign just going gangbusters. So people are looking at manufacturing more than ever before. It's quite exciting. Yeah. So this is what we're talking about today is R&D. So Neil, if you don't mind, I'm going to throw to you, and if you could tell us a bit more about First Graphene. And I know it's a publicly listed company. Could you tell us about the foundations of First Graphene, how it came about, and where you are today?
Absolutely, absolutely, yes. Thank you. First of all, thank you for allowing me the opportunity to talk today. It's great to do this. This is actually my first webinar, so this is great. A new format for me, so it's fantastic to be part of. It's a lot easier than flying somewhere to go to a conference. I can do this from the comfort of my own office at home. So First Graphene, actually, funny enough, first started out as First Graphite. We had access to, so we've got mining and exploration licenses in 2 mines in Sri Lanka, where we have access to this high quality graphite ore, which is 97% plus pure carbon, heavily ordered crystalline graphite. And the guys at the time were really trying to figure out what to do with this material, you know, looking at various industries such as batteries. And for obvious reasons, graphene came up quite early on. And I believe this was well before my time at First Graphene. I believe then they started getting this material, and they approached the University of Adelaide just because of the obvious connection with the Graphene Research Hub that was going on there. And they engaged, I think it was Professor Dusan Losik, who was running an electrochemical project to produce graphene that way. So they approached them. They gave them samples of the graphite, and without any further processing, they were able to determine that they could manufacture high quality graphene using an electrochemical process. So that was about 2015. They did it in a 5-litre beaker. They produced some graphene, and the analysis showed a very good, very pure graphene material from that. So the board got together at that time and kind of thought, well, it can be done. And we have access to this material. We've essentially let nature do 99% of the work. It's all already heavily audited. All we have to do is pull that graphite apart. How hard could that be, basically, on scale, if it's doable in a 5-litre beaker? So the board got together and had a chat and said, well, what's holding graphene back? Why has, this material was isolated in 2004 with sticky tape, essentially. Like, why has it not been pushed to the market already? And part of that was there was no large scale production facility out there. There was a lot of people playing around with graphene on small quantities, and it was relatively easy to do so. So they said, well, let's take a very bold approach and let's build a production facility. We had no purchase orders, we had no client base at the time.
That is bold.
So it was kind of a build it and they will come kind of philosophy. So in 2016, they built the first prototype cell, what we believed to be. So we went from a 5-litre beaker, essentially, in the University of Adelaide, to a 150 kilogram prototype electrochemical cell. And it's a good thing we took a big step forward. It's a relatively large jump up in scale, because it wasn't a linear learning. Like I said, we kind of had an optimistic approach of how hard could it be, but it turned out to be quite difficult when we were upscaling from a 5-litre beaker to a 150 kilogram cell.
But tell us a bit about the research involved in that, though, because what you're describing sounds like to me is not just research for the graphene product itself, but you must have been researching your potential customer base.
Well, absolutely.
Researching the sort of equipment that you would need to set up production. So research can be quite broad, right?
Yeah, I mean, the first step here was could we make the graphene scale? That was our first step. We were researching the equipment because these kind of electrochemical cells to do this didn't exist. So there's no textbook on how to do that. So we had to kind of take a bit of a trial and error approach on that, because there are a number of variables that come into place as far as the electrochemical reactor is concerned. The shape, the current, the resistance, and the resulting voltage that goes through the electrolytes that are used to do that. None of that, we had a rough understanding, which came from, we had the academics giving us the support through the University of Adelaide, which identified, the electrolytes, what we need to use, and some rough parameters of what we used with that, and then upscaled it. So once we ran that, we kind of went through an 18-month period stripping down that cell and putting it back together again and tweaking it slightly before we got it to a point where we could confidently produce graphene on quantity. And then they upscaled it again in 2018 to the full-scale production facility in Henderson now. So that original cell was multiplied by 5 and then made into a commercial scale production cell. And then from that,
I was just going to say, so really the research side, the research and development was some 3 years in the making. Is that what we're talking?
Yes, somewhat. And that was just stage one. So that was producing the raw graphene from the graphite. Once we actually had that graphene, we had to figure out how to process it. So as Jackie could probably support me on here, graphene has quite some unique properties that create some interesting solutions from an engineering point of view. Something as simple as washing and filtering graphene sounds quite simple, but when you actually try and do that in practice, it opens up several cans of worms that we had to work our way through.
Well, that's a good swing to Jackie. I might actually ask you, Jackie, if you can tell us a bit more about the Graphene Research Hub. And it's not just the University of Adelaide. You've got quite a cohort that you're working with, and other commercial partners too, right?
Yeah, so First Graphene, obviously one of our commercial partners, but the hub is a collaboration between our 5 industry partners and 6 universities. So it has about 40 researchers across the universities, most of them based at the University of Adelaide with Professor Jason Lossick that Neil mentioned. But the focus has been very much on graphene, because this one material is such a game changer in this advanced material space. So we think of it like the next carbon fibre, where it is strong and lightweight, but also it's ultra thin and conductive. So it adds all these additional properties to it, like Neil mentioned, that has so many applications, which is fantastic. And one of the main reasons for setting up the hub is to further develop being able to produce graphene at scale and to consistent quality, because of course if you're making a product, you need to have batch to batch as consistent as possible, and this is where First Graphene has done it exceptionally well in being able to make graphene at different sizes, which is one of the properties of graphene that will impact the applications, and batch to batch minimal variation, which has been fantastic to see. So graphene, obviously carbon-based, natural product, so it can be very difficult to make that consistently. And that has been one of the clear things that has benefited, well, the industry, but also First Graphene, in being able to overcome those challenges, those fundamental challenges, and being able to make this a remarkable material more accessible for industrial applications. And
no,
then
it was great to visit. It was great to visit the facility there at Adelaide and talk with the professor. Duson's doing some great work, and he's very passionate about the work. Today we're talking about R&D, of course, but for those that are listening in and might not be familiar enough with graphene, could you tell us perhaps the top 3 uses that you're seeing for graphene at the moment, and what the future might hold?
Yeah, for sure. So with being conductive, there's a lot of interest in batteries. So it can be just small quantities can have benefits in having long-lasting, fast-charging batteries for electric vehicles, smartphones, that sort of thing. Also in coatings, because it is ultra-thin and it can block out oxygen, for instance. So we're seeing leaps and bounds in fire retardant coatings that First Graphene have been involved in, and anti-corrosive, anti-biofouling coatings for the shipping industry that Smart Technologies have been involved in as well. Building and construction for being so strong and lightweight, but also in like membranes and water filtration is another huge area. So lots of different applications. They're just some of them. I can keep going on, but
yeah, well, it is. I mean, it is being described as a new wonder material. And what I saw at your facility was some great research going on into all the various applications, but I'm sure there's more to come. And maybe back to you, Neil, could you perhaps describe to us, who your customers have become, and so, commercializing this new concept from research to actually getting dollars in the door must have been quite a journey, but you are a publicly listed company. So could you tell us about the results so far?
Yeah, absolutely. So obviously, as we were building the factory, we were also trying to build the industry as well. We were partnering with local companies, and being based in WA, the logical place to start was mining. Everyone over here is either mining oriented or supplying the mining industry in some way. So we started off very early on targeting polymers and composite materials for mining applications. So one such example was a company we're working with, a local company called Newgen Group here in Perth, literally just around the corner from our factory in Henderson. And they make polyurethane liners for sacrificial wear liners for the mining industry. Now, so we saw that as a good approach to get graphene into for the mechanical benefits, as Jackie mentioned. It's super strong, it's super light, and what we're trying to do is harness that in a composite material to boost the properties to another level. So we started working with them quite early on in 2019, and really trying to figure out how can we get this finished product, graphene powder, into the production facility and the production process obviously in a safe way, without too much disruption to their existing process, and what results can we get with existing commercially available equipment as well. So the first challenge was getting it in and running some testing programs. We saw some good benefits quite early on in a lab scale testing. So we were talking increases in tensile strength, increases in tear strength, increases in abrasion resistance, which is most important for them. So we quickly took that and ran with it and ran a field trial. The problem with mining is your field trials typically last a very long time. So getting feedback, there's quite a long lag there. So we actually had these, we selected a reclaimer bucket liner, 2 liners running the exact same reclaimer, both installed at the same time, one with graphene, one without graphene. We ran that for 62 weeks. After that, we took the buckets out, we measured them and got a result. So these have just been released quite recently, and we saw between a 4 and 6 times increase in the abrasion resistance of those liners.
Oh,
so whereas the conventional material was still trying to understand the mechanics behind that as well, but the original liner was obviously still somewhat intact, but it was starting to hole out, and the thickness was significantly reduced. The graphene liner was, like I said, between 4 and 6 times reduction in the abrasion loss. So that's just one example.
What you're really saying there, Neil, is what I see demonstrated right across the nation is that research and development is ongoing. It doesn't stop.
No, it never does, actually. Otherwise, my job would be a lot easier. So obviously, when you show those numbers to a mining company, they usually say, "Well, can we push that further?" And that's the beauty of it with graphene. This is really just generation 1 of graphene enhanced products that we're working on now. As we learn, and we learn more every day. The early adopters, like your New Gen group and the guys that we've been working with us closely from day one, they'll benefit from this the most, because we're already working on the 2nd generation of graphene enhanced products, and how can we adjust their production process to be better suited to graphene? How can we tweak the graphene to be better suited to their process? So it is an ongoing process, like you say.
I've got a question
many
here
industries.
Yeah, this is great. I've got a question from Stuart Allenson, who asks, we talked about the next carbon fiber, and his question is, are there any sustainable aspects that make graphene attractive relative to carbon fiber? Is there more benefits to using graphene as against carbon fiber, or?
Depends on the application.
Jackie,
sorry, no, you go.
No, sorry, you started.
Jackie?
Yeah, so it depends on the application, but things like graphene, you'll need less of it. We're seeing a lot of benefits from a small percentage of graphene going into the product, so you don't need as much. Yeah, it depends on the properties that you're after as well. It does come from a natural source. I'm not sure about carbon fiber itself. Neil, are you able to jump in there?
Well, what we're actually using graphene a lot with in these kind of FRP composites, we're actually using the graphene in the resin that holds all of these composites together. So we're not actually changing the carbon fibers themselves. We're actually changing the epoxy or the vinyl ester resin that kind of binds it together. And what that allows is for some quite unique properties that are more onto the thermal properties of graphene. Allows some heat to be better dissipated throughout the structure. You also see some increases in flexural strength and impact resistance. So the potential there would be, from a sustainability point of view, is maybe you could maintain the strength of your existing component, but take some weight out of it. So you'd be less materials going into it. Obviously, there's a shortage of carbon fiber around the world at the moment. The demand is only increasing. What we also see is we could probably use the graphene to boost the performance of traditional glass fiber reinforcements rather than using carbon. We could offset that with either another form of fiber, such as glass or nylon or polypropylene, whichever else is available, and get that performance closer to kind of bridge the gap between glass fiber and carbon fiber. And maybe we can use more applications in that. That's where I see from a sustainability point of view.
More research, Neil.
More research, yes. That's another area. Obviously, we struggle with the.
I have a question for you, Neil, from Wilma James, who asks, are you finding that you need to use innovations like with business process improvement, new marketing initiatives, perhaps finding the best business model? Are those processes as important as the actual R&D of the product? So as this business has grown, so research for finding customers, research for how to build the business in the best manner?
Absolutely, and that's where we're really focusing now, is strategically where do we target? Obviously, as we've kind of established, the applications for graphene are quite broad. It's been described as a disruptive technology in the fact that it can influence so many different areas. So we've really got to focus on obviously we've got to focus on the commercialization now of graphene, and how can we build first graphene itself into a cash flow positive business, and keep all of everyone employed and obviously all the shareholders happy. So we are obviously focusing our areas on designated sections of the market, which we believe will be more easily accessible in a shorter time. Obviously, things like energy storage are fantastic, and obviously the areas that we are allocating resources to. But we also have to focus on what can we use graphene in now. What's more, technology kind of driven, and what's how can we use it now actually? So areas like composites, areas like the polyurethanes, areas like concrete. Obviously large volume, relatively simple areas to get graphene in, and what can we get benefits from straight away. So we are targeting areas whilst obviously keeping our eyes on the energy storage and hydrogen production, and something that's quite sexy and quite obviously like, what's the word I'm trying to get?
Well, you're looking for the commercial outcomes now. The
That's
research is
exactly.
done. The research is now ongoing and building.
Yeah.
But the most important part for any business is getting that income. So what you're describing is good, but it's vitally important. We need that revenue, right? And this is where research becomes entwined with building a business. And so, Jackie, one of the things here, Wilma's just given me a follow-up question. Thank you, Wilma, and please keep all these questions coming. Wilma asks, is there funding from government for this part of the innovation process? Now, in my experience, that's working with things like Oz Industry and the Entrepreneurs Program. There's federal government grants. I know all the various state governments have grant opportunities now for business processes in general. But do the universities offer grants around this sort of thing, Jackie?
The universities don't have grants themselves, but are willing to partner with industry. So where there is the chance for scale up, for instance, you've got the basic research and then you want to scale it up into something that can convert into a product, or an existing product that needs to then go on to commercialization, there will be more likely to be government funding for that. But if an industry partner is willing to invest money, universities definitely accept partners, and then that looks good for a government grant, for instance. So you already have that chain of different groups in interest in being able to deliver those products and being able to make them at a commercial scale. So you've got the industry partner for that, you've got the IP and know-how from the universities, and then you're entitled to all these government grants, but the money not specifically coming from the university.
For those people out there that perhaps haven't engaged with the university before, you'll often find that the university leaders are more than happy to work with you and research to find the right grant that could fit the project.
Yeah.
So you don't have to do this alone. There's people there willing to assist, and I'm sure Jackie can help you in that as well. In relation to graphene, I've got another question here for you, Jackie.
Yeah.
These questions keep coming, so this one's for you, Jackie. What are the general steps between research into development, and do they happen simultaneously? So I guess that's back to commercialization, right?
Yeah, so you'll have a step of proof of concept. Oh, look, we found this thing. It has an application in this new area that we haven't looked at before. Where can we apply this? So we might go out and talk to industry about, is this of interest to you? Or industry might hear about it and come talk to us about it. So then the next step will be proving the concept and optimizing the process, and then scaling it up. But all of these things, in theory, they happen linearly, one after the other. But in reality, definitely, it's always going back. You can develop it so far, and then for the next step we need to go back and change a method, or we can't use that process after all. When it gets above a certain capacity, it's not going to work anymore, so you'll come back and look at the process and the R&D side again. So it is very much keeping on trying, keeping on developing it. Once even you've developed it, then you might want to optimize it. You'll look for improving it, improving the process, streamlining it, whatever. So definitely, it's all combined. Sorry.
This is good. Please keep the questions coming. Use the Q&A button at the bottom of your screen and keep those questions coming. Now might be a good time for our poll question. Today we have a poll which we'd like you to be involved with, and the question is: on average, how much do you spend on R&D in your business activities annually? So this is for everyone out there. Please fire away. And is it 5% of your activities annually, 10%, 15 or 20%? And if you don't know, maybe have a strategic guess, but we can talk about this too. So please go ahead and have a go at our poll there. And Neil, I'm going to throw to you because I guess the amount of research and development into any business is important. A lot of companies out there don't actually measure it as such, but there are benefits to having that as a separate line item. And you've got things like the R&D tax concession that can help. Do you have any indications around what businesses should be looking around their research and development costs?
Well, obviously that's depending on the industry that they're in. Obviously, we are still heavily invested in research and development, and we always intend to have a heavy aspect of our budget dedicated to research and development. No matter how far we go, we're always working on the next generation of graphene production and optimization of our current production process. We're also looking at obviously the applications as well. So we are heavily invested in research and development, and we always will have a decent size of our budget dedicated to that. What I do like to see now is obviously I'm engaged with so many different companies that are now pushing it, as I've seen an increase in demand lately, and even due to COVID, I believe a lot of people have actually sat down and focused on how they can improve the current production process. So I think we were worried at first that it would go the opposite way. Obviously, when things were all unknown and we didn't know quite what was going to happen in the industry, we were expecting people to maybe, put the lid on that one and then kind of put it to the side until, yeah, exactly. And then, but obviously everyone went into lockdown, everyone was sat at home, people needed things to do, and people started to look at their own production processes and their own products and where they can differentiate yourself from the competition or build new industries around that. So
it has been a transformative year, there's no doubt.
Absolutely. So we've had to do that.
Let's see if we've got a result for our poll. On average, how much do you spend? So there we are, if everyone can see that. So the majority is on 5%, is on average how much they spend on their R&D activities. 10, 15, and 20%. I did meet a company last month that are investing 25% into R&D, which I thought was amazing. But they're certainly reaping the benefits of having the right research partners, putting that research and then development into action, and now earning an income from it. So this is what we're hearing from Neil today, is that they are now earning an income from that research in the early days, but that research is ongoing. The development only grows. And you've heard Neil say that they're looking for new and more innovative ways to use graphene. So I'd hazard a guess and say we ain't seen nothing yet. Is that right, Neil?
Oh, it's very, very early days, yeah. So definitely interesting to keep watching the space for sure. I mean, the inquiries only coming more and more, and the applications are obviously getting more and more interesting as we go along as well.
So one of the questions here we have is from David, and David's asking, what is the costs for production of graphene? Is there a general cost for production of graphene, or does it vary?
It varies depending on the size. As Jackie mentioned earlier, there are different grades of graphene. We manufacture four main grades currently at our production facility. And that's just your lateral platelet size. You've got to picture graphene like a business card in shape. It's relatively flat, and your aspect ratio is your XY to your Z kind of ratio. So your bigger platelets, the biggest ones we manufacture are 50, and then we go down to a 20, 10, and 5 micron range. The smaller they get, the more time is in processing. So obviously the costs increase associated with the smaller particle sizes. So depending on the application, it depends on the cost of the graphene.
Very good. Thank you for that. Now I've got quite a few questions, so we might just go through some of these to get everyone their response. So Reed Ossington asks, thinking about the big picture, how would you recommend organisations set up their R&D processes if it is new to them? For example, and I might ask you this, Jackie, for example, would you recommend quality function deployment as a starting point to get new product solutions into the market? So I guess, what are you seeing as far as setting up R&D in the first place? How important is that, and what's some practical steps for people to perhaps engage with the universities?
Yep, so it's worth engaging with universities just to see what's possible. So look at the suite of products that you have at the moment. Where do you want to make improvements? Is it enhancing existing products, streamlining the processes, or making a whole new product? So it's worth talking to the universities to see what is available, or getting in touch with some of the research directly. You can contact commercialisation partnerships, they call them, commercialisation and partnership managers. They'll be able to help with the suite of projects on offer and put you in contact with the professors involved and their research groups involved. But even reviewing some of the, for instance, the ARC Graphene, the ARC Research Hubs are producing a range of products that may be of interest as well. So just scoping out what might be available, but even if you don't know, just talking to the universities, because they're always willing to help in talking to you about your needs and where you want to go with your manufacturing process and your products.
So for everyone out there, I would certainly encourage you to reach out to the universities. I think what you're saying there, Jackie, is that every university would help to support you and perhaps put an R&D plan together with you. But I would also encourage our members to reach out to your local Oz industry representatives, speak to the Entrepreneurs Program people. There's a range of support measures there to help you get started on this R&D journey, or potentially grow your R&D from what you're doing currently and see what the potential is. What we're seeing with this new focus on manufacturing is like never before. And so again, everyone is focused on manufacturing to support your business, and there's never been a better time to engage and see what the potential is. So I think that's great. We've got plenty of questions here. So this one for you, Neil. Wilma asks, has it been difficult for First Graphene to use the research that it is funding or partnering with universities to discover in its business? In other words, is the investment into the university research paying off?
Well, absolutely. We wouldn't be here without the information and the data and the scientific support that came from the universities. Like I said, we got the graphite and we were trying to figure out things to do with it. And we took it to the university to say, well, can this become graphene? So that was our step one. As you said, we were looking for something to do with this material essentially and commercialize it. And then that's how we built this. So ultimately, yes. I mean, and the research and the support that we get from the universities in the other aspects. So on the application side of graphene. So Jackie mentioned there's a fire retardant paint program that we were running through the University of Adelaide. We did a lot of concrete research through the University of Adelaide. So that gives us the foundation and the knowledge and the understanding of the graphene, and so we can bring that to market. So we need to build on. Obviously, we need to eventually push it commercially, but that gave us a good foundation to start commercializing this product.
And now a shout out to Angela Doyle, my colleague in Western Australia. Ange is based in Perth and has been out to First Graphene's facilities in Henderson. So glad you could join us today, Ange. Angela asks, it sounds like for both of you that research that's been done has always been in collaboration with other organisations, such as research organisations, but also customers. What have been the benefits of collaboration for you? So I guess in this context, I'd be asking you, Neil, about how do you find collaborating with your existing customers? What do they feed back to you, and how does that help First Graphene to grow?
Well, that's ultimately the most important feedback. Is obviously we need to get things out of a lab and out of the research institute eventually and get it into a commercial production process. So they give you the honest feedback. They obviously will say, well, no, that doesn't fit with our production process. I mean, we can show them benefits in the lab, but ultimately if it disrupts the current production process too much, they're not going to adopt it. And that's why we found, smaller scale kind of owner operated businesses are often quite quick to move. We're obviously engaging with larger companies, but that's quite a slow process. Whereas your smaller companies can move quite quickly and adapt to that. So the collaboration with those is we work very, very closely with all of our clients because we need to educate them on how to use the graphene and how to actually get it into their process in the most efficient way. The key to get graphene to work, it's not as simple as just throwing it into an existing material and then it gives all the benefits. There are some processing limits that need to be adhered and followed. You need to get that graphene plate that's well dispersed, for example, as we always preach dispersion. So we work very closely with them to help them use the graphene in an optimum way so they can get benefits with them. So it's more of a relationship we get.
In that case too, Neil, the benefits would be that the customers can find a trusted partner to come back to you and say, hey, we've got an idea we're not sure about. Can you work with us to develop this new product? Is it possible? And so I guess that's building customer trust. It's helping your business to grow whilst your customer can grow along with you. So this is a good example of research and development really helping to boost industry in general. Absolutely.
So, I mean, we usually try and tie everything in. So we usually have a commercial partner that we're dealing with as ourselves, and obviously the knowledge that we're building on the graphene industry. And we're always working very closely with the universities as well to kind of approach it from all three angles.
This is good. Okay, over to you, Jackie. We've got a question from John. He says that we would like and we need to do more, but it's a significant cost for our business that has limited resources. Yes. So just for me, I think what's important there, John, is that, and I'm sure Jackie, you'll agree, quite often, if you can get involved with a university project, you can collaborate with the university. It doesn't have to be significant cost to your bottom line. I find that there's many collaboration projects, and quite often other companies are looking for support partners. So perhaps, John, you could be part of a larger collaborative project, which could actually help boost your own business. What do you think about that, Jackie?
That's a really good answer, and also there are a lot of incentives through government as well, so you can get funding for it. There's the R&D tax incentives as well to look into, and also there are a range of options. So depending on what sort of research you want to, if you just want to start looking at something and give it a go, there may be an existing project that you can join. You could get an honours student or a small project to start. So there are certainly a lot of options. You don't have to invest largely in a long-term research project. If you just want to have a look, if there's one particular question that you want answered or one particular idea that you want to explore, you can work with university to create that project, and it might only be a small amount of funding required. If it's, for instance, an honours project that can be done within a year with somebody not extensively trained, that could give you your first option, an opportunity, and then you can assess the outcomes and assess how that has improved your business or not.
So I guess it's just worth having the conversation and seeing what's possible.
Yeah, and there are a lot of options around.
Plenty of questions here, and this one's back to you, Neil. And I'm going to combine a couple of questions here. So the first one is, has the R&D tax incentive been easy to use in terms of compliance? But I'm going to combine that with from Kieran, who asks, how much R&D time is spent on researching application areas?
So the R&D tax incentive is obviously very helpful. We've been running that through since day one, essentially. Relatively straightforward. I mean, when it can seem quite daunting, and once you start working your way through it, it's actually quite simple. I don't handle that personally at First Graphene, but I've done it in previous roles in other companies before, and it's relatively straightforward. It doesn't require much time or too much information anyway. So it's user friendly, I think, as they can possibly make that process. Now, on far as the applications R&D side, we obviously have full-time staff dedicated to that 100% of the time. So that is their role. We have a materials and development lab here in Henderson as part of our factory off to the side. So that's focusing on composites and plastics and any other chemistries that we're working with locally. We also have a lab at the Graphene Engineering and Innovation Centre, which is in a part of the University of Manchester in the UK. So I believe we have 5 people there at the moment, and they're doing full-time research on different applications. So we are running an energy R&D project there at the moment, and they also provide us with any technical support, so they can do SEM, TEM, they can do the top-end science that we need to help support any developments that we're working on over on this side of things. So we have a dedicated research team on the application side of graphene.
That's great. Thanks, Neil. We're certainly hearing about how important R&D is, and we saw that on the smiley curve at the start of this presentation. Jackie, over to you. Bill asks the question, what are some of the more successful programs that actively promote and drive academia and industry together for R&D commercialization projects? What sort of funding, what sort of programs are available?
Yeah, so the ARC has a range of programs, particularly the linkage program. So a linkage grant is the best way for early days of R&D. There's commercialization opportunities through, I think it's the business, is it government business department, Michael?
Yeah, you can look at business.gov.
Yeah.
That has a lot of the information.
Business.gov, that's the other one. For a longer term project, you might look at CRCs or a CRCP, which is like a 3-year, for instance, program where it's government funding to commercialize, to make a commercial product. So it's really to take research from a high level TRL to a commercially viable product. So there are some government opportunities around that. Down at early stages of R&D, so just getting the proof of concept or the next stage after proof of concept, look to the Australian Research Council, and they are often the best way to partner with industry and universities.
And again, I would recommend that people,
and the hubs.
Yeah, that's right. Again, though, I would recommend that for everyone out there that you reach out to your local Oz industry representative, the Entrepreneurs Program, and other organisations that are there to support you. And of course, you can reach out to us at AMGC anytime, and happy to take your call or get back to you on an email. So feel free.
And contact universities, they can help as well.
Yeah, that's right.
Yeah.
So now I've got some technical questions here, so I'm going to throw these to you, Neil. For graphene, Stuart asks, from what he's read, the graphite process can be quite wasteful. For example, 30 kilograms of raw material to 1 kilogram of graphite flake. Is any graphene R&D focused on reducing that wastage?
Well, that's not entirely accurate with the material that we're using out of Sri Lanka. It's like I said, it's 97+% pure carbon. So we've essentially have no real big waste stream as part of our process. The ore goes into our process straight out of the ground in Sri Lanka, how it's processed. And then it comes out of the cell. So it's a closed loop cell. We don't really have a waste stream. We pick off some of the impurities, which is a bit of silica, a bit of iron, and that just gets scalped off early on in the process. So there isn't a huge waste stream. And that's what's quite unique about the material that comes out of Sri Lanka. It allows us to do that. We are working on next generation reactors that will allow us to use graphite sourced from anywhere in the world, but that would be a future development. So we don't really have that problem yet to address any significant waste stream.
Okay, great. I've got another question from David. Sorry, Jackie, I'll come to you in a second.
Yeah, sure.
David asks, the major issue with using graphene in industrial products is that the cost needs to be about 0.05 per gram. Is the cost of graphene production around this mark, especially for mobile phone batteries or car batteries? Over to you, Neil.
Well, obviously, the cost of graphene was a limit to the industry that we established early on. We're doing what we can to bring that down. The benefits of graphene come at very low addition rates, so that's where we see the cost per benefit becomes more accessible. For instance, when slightly off topic from batteries, but we deal with concrete, for example, we see an optimum increase in properties at 0.025% addition rate graphene. So it's very little amounts are added to get just over a 30% increase in compressive strength in the cements that we were working on, and that was again research done through the University of Adelaide using our graphene. So graphene is not the cheapest additive out there in the world, but the addition rates are very low. So you get your cost benefit comes in. Obviously, depending on the industry, so certain industries like bulk materials can't absorb even very little costs, but for premium or even bulk materials like concrete, if the addition rate is low enough, it can be commercially accessible.
Okay. And Jackie, we were talking about waste, and you had an answer there, but I'm going to combine these couple of questions to that as an extension. Stuart says that having previously worked on sustainable concrete, one of the challenges is developing standards. Is there any R&D focus on developing or meeting product performance standards? And also, Peter adds, what are the challenges to managing mutual expectations with collaboration partners? Over to you, Jackie.
Yeah, so with dealing with the different partners, it's mostly about keeping the lines of communication open. We need to have discussions. We need to be very clear on our expectations and the roles and responsibilities of each of the partners and which areas they're going to be working on and which areas another partner will be working on, for instance. So it very much comes back to talking to everybody and making sure everybody's kept in the loop about what they want and very clear about what the expectations are around that. So I'll go to Neil in a second about the sustainability standards for concrete, because I think that's more of his area. I just wanted to mention that graphene is, it comes from carbon, so it doesn't necessarily have to come from graphite, but the source that First Graphene have is remarkable in its purity. So where the numbers around the waste come from is from a different source of graphite or a different type, where you get more of these challenges. But also you can get graphene from recycled plastics, for instance, and from sugarcane carbon. So we do have one of our projects with Clean Future Energy is turning sugarcane into batteries, turning it into graphene and then into batteries.
But
so
not graphite at all.
No. So as long as you have carbon, you can get graphene.
Okay.
There is the question of the particle size and therefore the application, and First Graphene is unique in that it can produce the largest particle size, which is what you need for many applications. But you can get, for instance, sustainable sources, like renewable, I guess, sources of graphene.
So Jackie, on graphene, this new wonder material, where does Australia find itself on the world scale as far as this research and the development of this new material? Where are we in the world?
Interesting question, because just by comparison, the EU have $1 billion with a B dollar graphene specific research that they've been doing for the last 10 years. But graphenes aren't graphenes. So the graphene that we're working with is normally called bulk graphene. And that can be made from the different sources, but First Graphene do exceptionally well with their graphite. Now that graphene can be used for things like the building material and incorporation into 3D polymers. So we're doing exceptionally well in that space. The other space you might hear about is it's called chemical vapor deposition. It's a different type, and that's used for things like the mobile phone touchscreens, for instance. It could be incorporated into something like that. We're not doing as much in that field as they are in, for instance, the EU. But in terms of bulk graphene, the manufacturing's gone leaps and bounds. And with First Graphene having this consistent, reliable source of it, we're able to now start incorporating, well, they already are, they're incorporating it into products. So, yeah.
I've got, this will be our last question. So thank you to everyone for submitting your questions. Malcolm says, and I'll throw this to you, Neil, how can a blue sky idea get off the ground? In his own experience, he's found that university or the development sector don't have an interest in an outcome if it's too blue sky. So you've had some new ideas that you've researched, and then you're now developing them, Neil. What's been that journey, and how do you find, is it difficult to get people on board?
Sometimes, yes. I mean, it can be quite daunting. I mean, there's always the chance of failure. You don't really know the outcome, obviously, a lot of times. But the best way we've had, and the approach we've taken, is to just start, basically. Stop overthinking it really, and really just have a go. And that's what I think has been really good with the attitude that we get in Australia and this side of the world, is people are more willing to just have a go at it, have a crack. And that's with a new material. It's a very good approach. I mean, when we deal with companies in the UK and EU, we often find that they're quite more conservative on that approach, whereas on this we have that good attitude. So I think there's no time like the present on these kind of projects. And yes, it's the more out there, the less kind of the more out there the idea, the less kind of support you might find. But you might as well just have a go.
Yeah, absolutely.
Yeah.
And so feel free to, for everyone out there, reach out to any of us. You'll find each of us on LinkedIn. We're more than happy to assist you on your journey. We are recording this session, and it will be available later this afternoon, or definitely by tomorrow, for people to watch again. And so please put that into your favorites. But Jackie, I guess what we're hearing today is that research is vital, but equally with the development, you've got to turn that research into action. And so as an industry here in Australia, we're relying on companies like First Graphene to commercialise the research, grow high-skilled jobs right here in Australia, and develop products that we can export globally.
Yeah.
So people can reach out to the Graphene Research Hub. You've got a great Twitter feed, which I follow all the time. Some great research coming out on their Twitter feed, but I'm sure reaching out to your website and other ways to communicate are important too, Jackie.
Yeah. Yeah, absolutely. Do get in contact if you'd like more information or if you want to develop a link or discuss some ideas.
Very good. So here's some of the final slides. What we've talked today, just at a glance, that R&D is just the first step of the smiley curve. It's the start of the manufacturing value chain. And remembering that it's accelerated at that extent because you can create so much more value by focusing on R&D as just one part of that value chain. It's often undertaken when a company is looking at ways to introduce new products and services, but we heard Neil say that R&D is ongoing, and it should be. It's undertaken when a company is looking at ways to innovate current products, but also services. And we'll touch on servitization later in this seminar series. R&D is essential to remain competitive and to understand the current conditions of your market. Early on in this talk, we talked about researching your customer base, researching to find out who your customers could be or even should be. So R&D is very broad. Manufacturers can collaborate with research institutions, and we heard Jackie talk about the various ways that the Graphene Research Hub is doing exactly that. So it's been a great conversation today. Thank you for all your questions. Can I recommend that you have a look at our Manufacturing Academy, which you'll find by just Googling Manufacturing Academy. Join us for our future seminars over the next few weeks, where we'll be talking about the next one will be the value of design and adding value to your manufacturing business by looking at design initiatives. Have a look at our events where you can register on the events page. Today we've talked about graphene in particular. Can I recommend that you have a look at our projects page on the AMGC website, and in particular you'll see our project underway with a company called Geofabrics Australia, where they're using graphene to put into fabric materials. And so it's a very good project, and it's outlined in great detail about the ongoing project that AMGC has going with Geofabrics. If you're not already a member of AMGC, feel free to join. It's completely free, and we welcome you to get involved with the manufacturing here in Australia. I talked about the Manufacturing Academy, where you'll see business leaders sharing their insights into how they're growing their business today. And of course, we also have the COVID-19 Manufacturers Response Register, which is expanding all the time. So please feel free to have a look at that if you're in need of products or if you're producing products to sell. It's a fantastic platform that continues to grow. So please reach out to us on LinkedIn, have a look at our research page for our latest documents, and keep up to date with our upcoming events where you'll find us all over Australia. So thank you for joining us today, and please thank you for our speakers. Glad you could join us. Have a good day.
Thank you.
Yeah.